Hi, I'm Jay Tyler, and welcome to our fifth masterclass. Today's curriculum is going to be streaming and leveling up. We've got three excellent panelists today, gentlemen who I've worked with for since the beginning in Wheatstone's streaming world. We've got Rick Bidlack from Wheatstone and VoxPro, and we've got Eduardo Martinez and Tim Labelle from the StreamGuys. Like I said, I think it was about 5 years ago we started working with everybody, and I think from Wheatstone's point of view, I would probably thank Windows for getting us into streaming. I mean, it was a natural progression with the WheatNet ecosystem and having other devices on the network. But it seems like around 2019, 2020, Windows started doing these massive updates. And the old faithful, tower computer running a sound card and some third party, sound processing software with an encoder became unreliable. And Windows made it very, very difficult for engineers. And probably around the mid 2010 20s, radio stations and television stations started treating streaming like transmission. It had to be up. It was mission critical. It was 24/7. And between the combination of demand from the Wheatstone customers and the industry asking for an embedded appliance, that's how we sort of got into the whole streaming world. So we picked a hardware platform that worked for us. We knew we wanted to build our Stream Blades and Wheat Streams and even the new Duo on a Linux platform, and it needed to be reliable and it needed to be resilient, but it had to have the key features. And what we're going to talk about right now is I'm going to turn it over to Rick Bidlack, and he's going to talk about the implementation that we've done with our streaming products and how we've created our whole streaming platform from the ground up. So, Rick, I'll hand it over to you.
Okay, welcome, folks. I'm going to share my screen at this point. I hope this works now. And let me pick this one. We all see this at this point. So when I came to Wheatstone, it was because of earlier work I had done with the VoxPro editor, which is a Windows application. And that was going pretty well. And we had just released a new version of that, VoxPro 7. And I no longer had anything to do for the company and was kind of twiddling my thumbs. And they came to me and said, well, streaming is the new FM transmitter. It's all going to streaming these days. So they made me the person responsible for figuring out how to do streaming, because we had never done it before. And so I figured out a few basic things, but I had no idea what to really do. So I started looking around for people in the business that we might ask some questions of, and stumbled upon StreamGuys and reached out to them, and they responded, and the rest is history. So a number of the design ideas that are in StreamBlade are actually due to them and their input. So what I have here in display is a sort of 40,000 foot schematic of what our stream encoders do. On the left side, this is the source of your audio. Your audio comes in either as the program, which is either coming from the automation system or from microphones, or maybe you have another feed coming to the studio. It doesn't really matter. That is the ingest audio, and so it can come into us in a number of different ways. WheatNet IP, AS67. We're starting to play with wrist streams now. And then our Duo processor also accepts AES-3 and analog audio. So that comes in, and the first thing it hits is a 6-band equalizer. If you all are familiar with any of our other products, it's the same 6-band EQ that is built into almost everything that we make. After this, there's a 5-band AGC. The purpose of the AGC is first of all to do a phase alignment of the waveform. So if you spend a lot of time looking at waveforms, you know that a waveform out in the wild is rather unruly. It can have a lot of out of phase components. It can look very asymmetrical. So one of the things that the phase alignment does is just to tame the waveform. It makes it more symmetrical. It's more well behaved that way, and it fundamentally easier for the AAC codecs or the MP3 codecs to deal with, which I'll get to a little bit more later. The next component in this is either a limiter or a loudness controller, and all of our encoders have both. You can switch between either limiter mode or loudness mode. The limiter, both of these are also, they have your stereo controls and the bass controls as well. The loudness setting is something you can control as the user. So all of these components together, these comprise what we call the DSP preset, and all of our encoders come with a library of, I don't know, what do we have, 40 or 50 presets? And of course, these are all customizable as well. After the preset, this is an optional step. The Nielsen encoding, or if you're in Europe, Kantar encoding, that takes place, and then it goes back to the monitor, back to the studio. So that's what you're using to listen to your DSP presets, basically, and just listen to your levels and what is the sound of the studio, or the sound of the program, I should say. After that, it's given over to the codec, which is doing the audio compression. It then heads off to the packetizer, which is based on the transport protocol, which you've worked out with your CDN. It's either IceCast, it's HLS, it's RTMP. MRV2 is Triton's protocol, or just plain old RTP if you're using the stream for in-house purposes, things like that. So that's the basic job of the encoder. After it goes to the packetizer, that stream heads off to the content distribution network, the CDN, of which StreamGuys is an example. And then it's their server that's actually serving the tens of thousands of listeners that are out there in the public. The other component to all of this is metadata. And metadata usually also comes from the automation system, along with the audio. So it is synchronized more or less with the audio. And it comes in over UDP or TCP. It's text-based invariably. Sometimes it doesn't. Sometimes from the automation system, it will go up to like an aggregator or a metadata cleaner, and then come back from there. In any case, it comes into the stream encoder. I'm going to show you some of this later. The way it comes in is not the way in which it has to go out. So it has to be transformed before it can go out to the CDN. And the way we do that is using an embedded scripting language called Lua, and this was actually Eduardo's idea for how to use or how to deal with metadata, where we have a situation basically where the format of the metadata coming in can be virtually anything, and the format that it needs to be in as it goes out is also virtually anything. So we're mapping anything to anything, and the only way to do that is using these transform filters. After leaving the transform filter, depending on the protocol, the metadata is going to be either injected into the audio stream. So this is what we call in-band metadata. And that would be HLS, RTMP, Triton's protocol, MRV2 are all in band. Or if it's IceCast, it's out of band. It takes a separate route to the CDN server independently of the audio, which means that it can in fact lose synchronization with the audio. That's just a side effect of IceCast. So that's all I wanted to say at this point, and I think we're going to hand it off to the StreamGuys to talk about what the purpose of the CDN is, what services the CDN is providing. So I will unshare my screen now.
Awesome. Thanks for that, Rick. So we're going to take it
Sure.
from the egress point at the very right-hand side of Rick's diagram and pick it up from there. Let me share my screen. Let's see. All right. So my name is Eduardo Martinez. I'm the VP of Technology for StreamGuys. I'm joined here with my colleague, Tim Labelle, who'll be helping us walk through some of this. We're going to pick it up from where Rick ended, kind of at the CDN and contribution network. So everything after when the encoder leaves the facility. We're going to quickly cover a couple of just streaming trends here.
So I'll cover the ad replacement, cloud distribution, and then Ed will get the more technical ones. Two trends we've seen for a while and we're still seeing is more broadcasters moving to ad replacement for their streaming. Now that might just be out of market, but with more and more listenership continuing to happen on streaming over the broadcast, we're seeing broadcasters start to realize if I just bundle this in simulcast, maybe I'm giving away a lot of the value that's in my streaming audience to just people that are, or advertisers that are sponsoring my broadcast or buying advertising in my broadcast. So we're seeing, it used to be just the largest players, but now we're seeing a lot of the medium and even smaller players in the radio space start to look at and implement ad replacement. Like I said, there's different strategies we see there. Is it just out of market? Is it everything? But identifying that those digital streaming listeners are valuable and might even be the lion's share of your listenership is something that I think is driving this. The other thing we're seeing is cloud distribution. So this is actually using the streaming technologies, including what you're seeing from the StreamBlade and the Duo for backhaul, where we're taking streaming technology and using that for distribution for syndication or getting it to the transmitter, things like that. A lot of the technology can be used in this way, and we're seeing maybe concern over the long term of satellite. What's that going to look like? What's it going to cost in the next 5 to 10 years? And so we've for a long time, and still to this day, we're seeing broadcasters and audio networks start to explore what does cloud distribution look like? How can I use streaming technologies for my distribution needs in addition to streaming to the end users?
And on the protocol side, on the evolution side of it, we've seen the uptick in purpose-built protocols that are used to ensure a smoother connectivity from when when the signal leaves your facility into the CDN ingest. So purpose-built protocols like SRT, which stands for Secure Reliable Transport, RIST, which is something that Wheatstone supports today, protocols like ZXI are seeing an uptick on the contribution side. Traditionally, a lot of these protocols come from the video side, but we are seeing an uptick in the use on the audio-only distribution as well. On the egress side of it, when we talk about the evolution of protocols there, ultra-low latency streaming has seen a big uptick for our big sports broadcasters there. So traditionally, broadcast streaming has a typical delay of around 30 seconds by default when you're using HLS. We're seeing folks use ultra-low latency streaming to bring that delay significantly down. So when you have sports broadcasters that are doing live sports and you want to be feel like you're in the stadium for your end listeners, ULLS makes that possible today. The focus of our talk today will be around HLS encoding and the various benefits that are there. So in terms of HLS streaming and why it matters, we can begin by talking about what is HLS. HLS stands for HTTP live streaming. It's Apple's adaptive bitrate streaming protocol. We take a live linear stream, we segment that into smaller chunks, and that gets distributed in a playlist to where each player consumes that out. We can have multiple quality variants for adaptive playback. So similar when you're used to looking at YouTube or Netflix, when you have a high, medium, low, this technology is available for audio streaming as well. So you can have a higher and a low bit rate to optimize on your network conditions there. We use standard web infrastructure for delivery. So you can use a traditional HTTP content delivery network like StreamGuys. You can set up your own server if you have small broadcasters, but this is all standards based on technology that runs most of the internet today. The magic of it happens in the manifest. The manifest, that M308 file, is just the extension at the end of a streaming link that guides the player behavior. So for example, we talked about cutting up a stream into different chunks. Those chunks can be in different lengths. The manifest defines the size of that. So you can have a playlist manifest with live stream chunks of 10 seconds each, and there might be 3 in the chunk, or you can increase that all the way up to 6 segments and have longer segments. At the end of the day, that provides added resiliency on the broadcast. Why does this all matter? We have with HLS universal compatibility. So across all major streaming platforms, major devices, in this day and age, a lot of folks are supporting HLS. It also brings scalability. We can leverage typical content delivery networks like StreamGuys to do large-scale distribution. So you save yourself a lot of the headaches of trying to have purpose-built infrastructure to scale your audience. To touch back on what Rick was talking about in terms of metadata, HLS is one of the protocols that has in-band metadata. So as each segment and chunk is being cut up into smaller pieces for delivery, the ID3 metadata is placed inside each chunk. So we don't have to do things like in the past. For IceCast, you'd have to short poll a stream and constantly, short poll the server to see if there's new metadata updates. With HLS, you get the benefit that each single chunk contains that data. So in each player implementation, you can pull that out individually. Reliability is another wonderful benefit of HLS. Using HLS, you provide seamless transition between networks. So you're in your house listening to your favorite stream, you're on your mobile phone, you're on your Wi-Fi, you walk outside, you transition to a cellular tower, that stream stays hitless and you're in tune and you're still listening to the broadcast. So no more start and stop streams when you switch from Wi-Fi to 5G and vice versa.
And if I can add a couple things here.
Most definitely.
On the reliability side, we anecdotally, when broadcasters switch from IceCast to HLS, I hear their support desk people say, we get less calls from people saying there was a problem with the streaming, right? There's always some, but they get less calls. We also recently did a study too, when we've been moving customers from IceCast to HLS, we'll see that their average time spent listening actually increases by a pretty meaningful percent. We're seeing like, on average, listeners are staying connected another 5 minutes or another 3 minutes. And that's because that protocol, you can just listen to it forever. As long as you don't have long internet outages, the listeners will stay connected. They're driving around, they're switching Wi-Fi to LTE, they stay connected. So those are 2 real world reasons to use HLS.
Most definitely. So on the distribution side of it, there's two pieces to the puzzle. There's what we call the contribution network, which is a purpose-built. Think of it as the on-ramp to get your content into the CDN. So at that last image that Rick provided, where it says, your stream is leaving the CDN, the contribution network is the path that your stream takes to get into the CDN, which in this case, it could be StreamGuys, it could be everybody else. So the contribution network is making use of HLS. You can have encoders that can natively segment to HLS, and we can ingest that. So all of the reliability that Tim just talked about from the consumption side of it is also available for the contribution side of it. So when you're sending an HLS stream packetized over the public internet, and there might be a little bit of packet loss or jitter, we can overcome that, and it's a seamless experience when you're ingesting that content into the CDN. CDNs also use HLS. It's the standard, for delivery these days when we're talking about live audio there. It just all the benefits that we talked about are kind of cohesively there present. So it's a unified workflow. HLS is both on the encoding side and the public side as well.
So we'll talk
Go ahead.
about three metadata use cases here. Actually, four. The first one here is broadcast to podcast. And all of these are ways that you can use metadata to automate things downstream that happen. So if you have a live program that you want to be made on demand, well, using metadata is a very easy way to trigger the start and stop of recording, to trigger the replacement of in-stream ad breaks with podcast ad breaks. So as long as you have tight metadata in your automation system and you have a great encoder like the StreamBlade or the Duo, and you're able to pass that to your CDN, you can then use other services to do that broadcast to podcast functionality and save that production time. So this is a big deal for live content that is repurposed because it's instant and there's no production time involved. The other is ad insertion. I think this is probably of the most commercial value because it lets you do ad replacement in your stream, where if you have listeners out of market, you can replace your broadcast ads, which might be local, to programmatic or other national sales ads that you've sold. And you can also replace in market as well if you wanted to. But all of that is driven on metadata. That's what lets that ad insertion timing be very tight. If you have bad metadata, you're going to have a bad ad insertion experience. And then the third one is source switching. The use case here is usually sports or other content that needs to be blacked out or embargoed, where you might have some programming that you can't stream, so you need to switch to other content. That can also be controlled with metadata. So if you're sending metadata in the stream and you have specific metadata syntax for when programming starts and stops that needs to be blacked out, you can switch to other content during that time and then switch back when that's done. And again, that's all driven off of metadata. The fourth is royalty reporting, which is a lot less fun than these, but everybody who broadcasts music in the US, for the most part, has to do this, where you need to provide a report to SoundExchange for your streaming performances, saying, hey, here's the songs I played, here's how many people heard them. That is almost always driven off of metadata as well. So if you send the artist and title and ISRC codes downstream to your streaming provider, they can provide you with that report, but it all comes from the metadata. So it's a very important engine to all of these things that save you time and help you make more money.
Most definitely. So here we start doing a little bit of a deep dive into broadcast to podcast. We're illustrating with the diagram a live linear stream. And again, it all stems and ends and starts and ends with metadata. So we have your regular live broadcast. The broadcaster from the radio automation system sends a metadata trigger. In this particular case, we have a start and stop trigger. Let's say you want to record your morning show from 9 to 10. You put that in your clock with the specific metadata triggers that are configurable. We have a backend system that's constantly monitoring for the presence of those metadata triggers. We then have a process that segments the content out, records it into that fixed file, takes that and then can publish it as a podcast episode. This could go into an existing content management system that you have. It could automatically get published to an RSS feed so that you have a new episode, and this can happen completely automatically. So this metadata workflow saves folks a lot of time from the production side of it because you don't have to constantly, start clipping heads and tails for shows. It can be completely automated. So if you have a popular news and talk segment in the morning that needs to get published to an Alexa, daily briefing, configure a system like this with type metadata to send stop and start signals and have the process be completely automated.
So here's a little bit more information on server-side ad insertion. As I mentioned, I personally think this is where the most revenue tied to metadata comes from. And these are high-level things that apply to anyone in the streaming space. I talk from StreamGuys' perspective, but everybody does this. But at a high level, server-side ad insertion is replacing content in a stream. Now, it might be a pre-roll, might be an audio pre-roll, or it might be replacing ads in the stream with other ads, or any content with any other content. It's really just content insertion and content replacement. Now, sometimes these things are client-side, which is like a pre-roll in a player, a video pre-roll. These things are always client-side because you can't stitch a video pre-roll into an audio ad or an audio stream. But a lot of audio-only ad insertion is done server-side. And the difference between client-side and server-side is server-side ad insertion is stitched into the stream itself. So it seems exactly like the streaming content. That's why ad blockers can't block it. That's why if you listen on TuneIn or you listen on iHeart or you listen on your website, you can hear those ads everywhere because any listener that's connecting to the streaming server is getting the server-side ads. And they're all dynamic and they're all targeted to each listener. The four of us here could all hear different ads. Now, client-side can be dynamic as well, but it is dependent on the media player. So you could only do that on your own website or your own app or on a media player that you control as well. The other thing that's very interesting about dynamic ad insertion is the targeting and the precision that you can use when running these campaigns. So you can run them for specific geolocation, zip codes, DMAs, states, countries. You can run them by device type, just Android, just iOS, just mobile, things like that. So you can get very precise on the users that you target. This lets your sales team sometimes get more creative for buyers that want a specific type of audience, as opposed to just selling a spot on your content. Now you can sell a campaign that targets their users specifically. And from what I've seen, this ends up looking more like how Facebook or YouTube or Google is sold, where they're targeting an audience. Maybe it's men 25 to 50 who are interested in golf. These are the types of things you can do with dynamic audio ad insertion. So it's a very interesting and deep space, and you can start to get very sophisticated campaigns with this technology. Now, direct sales is always the highest value, where you're selling local. But there is other elements here like programmatic ad insertion. And this is more outside of the encoder realm. This is into ad tech now. But I think for the purpose of this conversation, you just need to know that metadata needs to be tight. It needs to be there. So it all starts with an encoder that can support in-stream metadata and keep that in good time with the audio, because otherwise this is a terrible user experience. You can't roll it out. But once you have that metadata tight and in time with the audio, it opens up a whole plethora of opportunities here to use ad technology for these interesting things.
All right, so let's take a deeper look at the server-side ad insertion process here. Again, it all starts and ends with metadata. In this particular scenario, we have a live linear stream. We're sending signaling metadata. This could be ID3 or SCUDdy35. On the server side, we're constantly detecting the presence of that metadata. Once that metadata trigger is received, we can then trigger server-side ad insertion to replace a simulcast ad, for example. The ad decision engine from there has all of the users that are connected and all the targeting data that Tim was talking about come into play with the ad decision engine that picks a specific ad to be stitched in. So we can be listening in here on the West Coast in a local DMA for a station. The ad break hits, server-side ad replacement happens, and we can get a particular ad here in California that could be a completely different experience than you would get on the East Coast, for example. You see stations targeting, in and out of market DMAs to create these very, very personalized ad experiences for your end listeners. As Tim mentioned, if your metadata is not tight, if the timing of when you send that signal is off by, half a second or a second or two, the end experience to the listener can be just very jarring, because you might either get a little bit of audio on the underlying stream, the transition is not as smooth. So metadata has to be very, very tight for the server-side ad insertion experience to be nice and fluid for the end listener. Again, all driven by metadata. If your metadata is tight, that end user experience won't be seamless. Another interesting use case when it comes to metadata is what we like to call HLS source control. The scenario here is when you have live sports, and as live sports broadcasters, it's, you have to be very adherent to the rights of the actual stream of when can somebody hear that game. Are they in a specific DMA? Are they allowed to hear that game or not? Here we can use a stream. We can ingest a primary stream with HLS. Again, we're monitoring for metadata in real time. As soon as that piece of metadata comes in to denote, for example, a blackout broadcast, to say at this specific time, you have to switch that underlying source stream to alternate content for folks that are not in the specific area where you're allowed to listen to that game broadcast. That's where we can take another HLS stream, sub that in automatically so it's seamless. So in my previous example, we were talking about ad replacement. In this particular case with HLS source control, it's a more advanced piece of kit, because you're actually swapping out a full audio stream for that end listener. And that has to be seamlessly done as well. Again, driven by metadata. What happens if your metadata is not tight coming from the encoder? What could happen is, you miss the start of the game, or you're streaming part of that game to a person who's not supposed to be listening to it because they don't have the rights from a sports streaming perspective. All of this is seamless and dynamic and fluid, because we're using HLS as the core technology to swap out the stream for the other alternate stream. And then finally, this is an overarching view of the contribution network here that I'll let Tim jump into. But hopefully this is a wide overview of kind of how all the pieces of the puzzle fit. From the left-hand side for the source contribution side of it, from a stream blade, powered by super tightly aligned metadata. That'll feed into the rest of this workflow here. But at the key, we'd like to say that if content is king, metadata is certainly queen, kind of driving everything behind the scenes and making these workflows happen.
Yeah, so this contribution network diagram, the goal here is to help put this in perspective for you on where all of these components live. For this diagram, we have a camera here, but that just, that represents the streaming encoder. Could be a Duo, could be a Streamblade. And we can receive a whole variety of streaming protocols, all standards-based, nothing custom for us. And that goes into the contribution network. Now, the contribution network can receive HLS. There's lots of benefits to receiving HLS in the contribution network, but it does a lot of potential transforming of the content or automating other processes of the content before it gets to the delivery side. So that might look like transmuxing if we need to change between protocols. This happens often if you have an IceCast encoder, but we want to deliver HLS to the end user. We'll transmux from IceCast to HLS. Maybe, in the video workflows, we'll push to social media, or we send a video feed to social media. We could transcode. So if you're sending a high bitrate AAC and you want that transcoded into something else, that's doable here. It's always best to send everything that you want delivered to us in that native format. But if you can't do that, transcoding is an option. Translation of ad markers. Again, this is maybe more of a video workflow where you're looking at receiving SCUDY 35 and you want that to be ID 3 or vice versa. That happens in the contribution network as well. And then some of the other automations that we're talking about here, like turning a podcast into on-demand content, that happens in the contribution network. And then the content delivery, this is separate. So it could be a third-party CDN, or it could be us, where we're delivering those streams to the end users in HLS, ideally, because we have all of that resiliency that we talked about. The metadata is kept very tight. And that's where the ad insertion or the geo-blocking or things like tokenization for content protection happen. They happen on the delivery side. So this just helps you understand the framework of where things come from and where they go.
All right, I think we're going to kick it back to Rick now to talk a little bit more about metadata and what that looks like in the Streamblade world.
Yeah, I'm just going to interject for something here. If anybody has any questions, well, I learned more in the last 30 minutes than I have in the last 5 years. And I'm really excited to see how you guys have grown. It's amazing. You know, you guys are great partners, but awesome presentation. Thank you guys very much. We will turn it over to Rick, and I think we need to start a drinking game for this presentation. Every time somebody says metadata, they get to have a drink. It's but no, as you said, if content is king, the metadata is queen, and that was one of the big things that all of our customers, you know, one of our biggest customers was Town Square. They needed metadata. And when we were designing this, they were working very closely with Rick. And so I'm going to turn it over because I know Rick and Eduardo spent a lot of time on this. And to us at Wheatstone, this metadata is as important as the audio. So we're going to spend more time talking about metadatas and the Lua filters that we've created to get that metadata from your automation system or from other servers into the CDN so they can do everything that they do with it. So Rick, take it from there.
Okay, so one of the things that you might have come away with in watching Eduardo and Tim's presentation is that somehow metadata is all worked out and standardized, and everyone knows exactly what to do when they receive a particular signal. But in fact, that is not the case. It's kind of unfortunate. Metadata is very essential, but it has not been standardized at all. There's no such thing as standard types or tags or formats or anything like that. So I'm just going to show you some examples of metadata from the real world, what it looks like coming in, what we are looking for, how it has to be transformed to get to the CDN. So we'll start with this little example, two examples from the radio experience, TRE. So this comes in looking a little bit like XML. In fact, that is strict XML, and it's valid XML. Not that that really matters. We are looking for things like title and artist, first of all. We're also looking for the type of metadata, and usually we're looking for a duration. So this one up at the top, you'll notice that this is a commercial. COM is the type. It lasts 30 seconds. It has a title, but there's no artist. The rest of the stuff that's in here appears to be completely useless, to me at least. I don't know what anyone could possibly do with this. The listener, public, is certainly not interested in things like what kind of encoding you used or anything like that. This next metadata event is a song. So the type says Muse. Lasts 297 seconds, which is actually fairly long for a pop tune. And we have an artist as well as a title here. This next one here, this is from Enco. We have a title, we have an artist, we have a length. You notice that's 223.1 seconds. So we have a decimal number there. I assume from this that the group tag is what they mean by the category or the type. So music, fine. Notice the artist has some funny characters. The ampersand AMP semicolon, that's what we call an HTML entity. The end user does not want to see that. That's the ampersand character that's being transmitted in an XML document, and that's the way you have to do that because ampersand has a different meaning in XML. I'll look at a few more here. From iMediaTouch, this is sort of interesting because technically all of the different pieces of metadata are sent as attributes to a single tag, which is called entry. So it has a category attribute, and the value is UBC. That's the closest thing I can come to figuring out whether this is supposed to be a sweeper, a liner, a spot, a song. You know, the computer has to figure that out. It actually made me look at the Lua transform filter that we wrote for this, and what I learned there is that none of the categories coming from iMediaTouch say anything about song, although there is one category called spot, or is it com? Com, I think. So anything which is not a com is either a song or it's a like a sweeper, a liner, a station ID, something like that. And since we have no other information about that, we look at the duration. In this case, it's more than 90 seconds. Duration is obviously in milliseconds here, so 206 seconds. More than 90 seconds, we'll assume that this is a song and not a sweeper or a liner. Next, we'll look at some metadata from Wide Orbit. Wide Orbit tends not to put new lines in the XML that it sends out. In fact, it's not even strictly speaking XML. It just sort of looks like XML, but that's fine. We're just looking for certain tags, in this case, title, artist, duration, media type. The one on top is a song. The one on the bottom, the media type is unspecified, which is their this is Wide Orbit's term for anything which is not a commercial spot or a song, is unspecified. Notice also, like a lot of the others, there's a lot of empty metadata. For example, there's a trivia tag, but it's empty. There's something called milliseconds left, but it's empty. So metadata often arrives with tags containing no information. Okay, so this is the raw metadata. It can't be sent to the CDN like this. It needs to be reformatted in order to get up to the CDN. If it's going to an IceCast server, then there is a basic canonic form that all IceCast servers adhere to. And so the metadata update is in the form of an HTTP message, and you can actually type these directly into your browser window and play with your metadata that way if you have an IceCast stream going on. So the one at the top, they all start with the same thing. You have user and password at the CDN's URL. And then we go to /admin/metadata, and then the first thing, the first sort of query parameter that we're starting with is the mount, which is the endpoint that you're sending your audio to. The mode is upd info, which I assume means update info, but it's always abbreviated like that. And then we have query parameters, in this case, artist, title, length, and type. There's nothing required or mandatory about these. They might have slightly different names. Actually, we'll see that on the next one. So this uses song rather than artist or title. This is going to a different CDN. The message starts basically the same way, but in this case, there's only one query parameter. That's the term used for the ampersand song equals. That's the query parameter. Up in the first example, you have ampersand artist equals. So that's the artist, obviously. Ampersand title equals, ampersand length equals, and ampersand type equals. Those are all query parameters. In the second example, there's only one, which is song. And then we have fields within this parameter, which are separated by the vertical pipe, the vertical bar. So the first field is the band. The second field is the title. The third field is the duration. The last field is the type of event that it is. Those are important. That ordering is important because in the second example here, this is a commercial. It's not a song. So it's still, the query parameter is, ampersand song equals, and it goes immediately to a vertical bar, meaning that the artist field is missing. It doesn't exist. I actually took this from this prior piece right here, the TRE from AFN. So Armed Forces Network Holiday was the title of this one. And so that's what we're seeing here. And that's how this would be presented. This last example is just to show that you can add all kinds of query parameters, all kinds of pieces of information. So we've added an ISRC, we've added the label, we've added the duration, the album. Note that since these are URLs and they have to go over the public internet, URLs cannot have spaces in them. So that's what these %20 is URL speak for space character. 20 in hexadecimal is 32 in decimal. ASCII 32 is the space character. So that's what the %20 is. The %2F is the hexadecimal value for the / symbol. We can't use a / because that actually has a completely different meaning in an HTTP message like this. And then we see this down in the last example. So all the spaces have been replaced with %20s. If you look back at the metadata event that I took this from, it's the first wide orbit event here. So the album, you see rewind, comma, replay, comma, rebound. And those commas are then encoded as %2C. So that's, again, the hexadecimal value of the ASCII comma character. So we've just added more query strings here. There's just more information that the CDN could use or not use as they see fit. Other protocols are sent in-band. In-band means that basically it's being digitized and formatted in such a way that it can pass through or pass along with the audio stream in one form or another. So with RTMP was originally developed for Flash video, and it's still in use, even though no one looks at Flash video any longer, but RTMP is still a transport protocol that we are using all the time. Most RTMP packets are audio type packets, and so they have an audio header and audio data. But RTMP has other types of packets, and one of these is the info type. And so we basically set this up in the form of what are called action messages, action message format, AMF, and the data is serialized into formalized structures that we call AMF arrays. And then we wrap this entire thing into an RTMP info type packet. So what I've done here down at the bottom is, this isn't exactly what it looks like, but this is a sort of scheme of what is in the packet. So there would be a single byte indicating the next thing is a string. There would be a couple of bytes indicating the length of the string, 13 characters in this case, and then the actual characters in the string, in this case, the @ set data frame, which is what RTMP recognizes as the beginning of a metadata frame. This is followed by a 10-character string called on metadata, and then it's followed by an array of properties and values. So the first property is the name of the property, and it is a string with 5 characters, the word title, and this is followed by a value, which is also in the form of a string of 8 characters called backseat. And next we have the artist property and its value, a 25-character string. And notice now I can put actual spaces in this string because it's not going over the internet as an HTTP URL. It's going as digital data wrapped up into an internet packet. So I can have space characters in there, and I can also have the ampersand character in there. And then what is common in RTMP metadata frames is there will be a third property, which is called a URL, and it is in fact in the form of a URL, but we can put pretty much anything into it that we want, and then we leave it up to the CDN to decide what to do with that and pull things out as they see fit. So since this metadata is being injected into the audio stream, it therefore stays with the audio. It stays synchronized with the audio for the life of that stream. With HLS, it's kind of the same idea, but a little bit different in details. It gets inserted primarily in the form of ID3 tags, and ID3 allows you to name your tags whatever you like, so artist, title, duration, album, ISRC, or obvious names, and then give a value for each of those. Those are inserted into the MPEG-2 transport stream, the TS stream, which is also where the AAC frames containing the audio information are encapsulated. Other metadata, as Tim was mentioning, other signals that are used for switching content are most often written into the manifest file in the form of SCUDdy35 splice points. Oh, and I should say something about. Let me go back to here. This is sort of easy to see. How does a CDN know when to switch into add insertion and when to switch back to program? Well, mostly it's done by the category of the metadata itself. So most CDNs want to see 3 types of events, and so these would be song or music, com or spot, and anything else. Let's just call it other or sweeper or liner or whatever you want to call it. And the way add insertion works is that whenever the CDN receives a com or a spot, that's when add insertion begins, which is why you want your metadata to be tight with the audio, because it's going to happen at that moment. And the add insertion continues until it sees another type of event, such as song or other. That's the cue to switch back to the program. And there's a lot of ways to customize that, and there's a lot of ways to specify even that this particular commercial, you do want it to air as the simulcast, so don't replace it. So there's special conditions that might pertain, and that can all be transmitted to the CDN with the proper signals, as long as you and the CDN have negotiated this and you all agree on what the signals are. That's how that would work. So the transformation from raw metadata that looks like this to HTTP messages or digitized data that's injected directly into the stream, that is the job of the Lua metadata filter. I'm not going to show you any of those because they start getting technical very quickly. But Lua is a scripting language that anyone can learn. It's used for a lot of different things. The great thing about it is that we can embed it into our encoders, and it allows you to see the filters. You can edit the filters. You can customize them. You can look for, maybe your incoming metadata doesn't say, well, here, this category says UBC, so you need to write a filter that understands what UBC actually means, because it doesn't say song or com, it says something else. So that's the sort of non-standard part of the reality of metadata, is that you need some way to translate from whatever you have coming in to whatever your CDN wants to see, as well as your own needs. Are you doing podcasts? Are you doing add insertion? All that stuff enters into how the metadata is going to be handled and formatted on its way up to the CDN. So that's basically all I wanted to cover with metadata. It's much more involved than even this. So there's infinite variations here, but that's why it's still sort of on the bleeding edge, and we're all still trying to figure out how to handle it. And there are efforts within the radio community to standardize on metadata, but I haven't seen any documents yet that have been widely adopted. So, Jay, back to you.
Yeah, well, thank you, Rick. Yeah, it was pretty complicated. I don't want to hear anybody's complain about scripting WheatNet IP again. There's been a lot of chatter in the boxes, and I appreciate everybody answering questions. I have a question I think that people want to know. So I've got an automation system. I buy a Wheatstone box. How much time am I going to spend setting up my metadata to get it to the stream guys? The audio is easy for us. I mean, so like I got a wide orbit automation system. I got to sit down. I want to get my title and artist, for the user experience up to the CDN. How much time are we looking to do that for somebody that's never seen it before?
It varies. It depends on what you're trying to do. So we have a bunch of metadata filters that recognize certain widely spread automation systems, and we know there's a certain number of protocols, and then we deal with a certain number of CDNs, and they all have their requirements. And so we have filters that say, okay, if you're going from wide orbit via RTMP to StreamGuys, then here's the filter for you. It's the wide orbit RTMP StreamGuys filter. And it will do probably 95% of what you need to do right out of the gate. But there might be a few details here that we need to work out. The first thing that we usually have the customer do is just collect the raw metadata. So just enable the reception of metadata, because it will show up in your log, in the Streamblade log. And so you can see what it looks like in raw form. You can see what the tags are called. You can see if it contains HTML entities, if it contains like UTF-8 encoding, UTF-16 encoding, whatever. You can just see all that. And so then you select a filter that gets you really close to what you need it to do. And we see how that behaves, and we see what happens when you actually send that to StreamGuys or Triton or whomever. And they may come back and say, oh yeah, well, we saw the artist and the title, but we'd really like you to send the ISRC because we can do a lot with that. So do you happen to have that? Oh yeah, we do have that. So let's add that into our filter and send that along as well. So that might take a day or two to work out, depending. If it's an easy case, it usually takes, I don't know, half hour to an hour, but I have seen things that are more complicated and have to go back and forth between, 3 different parties. The automation system, what can it do? What kind of settings does it have? What kind of customization does it allow in terms of what it sends for metadata? And then, of course, the filter that you're using in Streamblade to manipulate this and reformat it, and then the third party being the CDN. What are they expecting? What do they want or not want? And so it can be a negotiation that might take 2 or 3 days in sort of worst case scenario, I'd say.
Okay.
In my
Eduardo,
experience,
yeah, Tim or Eduardo, do you guys have any other things you want to comment on that part of it, on the metadata? And because I know it ends up in your lap too when something doesn't happen. So they're calling you guys for support and they're calling you guys for answers.
I think the biggest variable I see is what's in the automation system right now. If you've never looked at metadata, you could get in there and realize, oh, everything I have is categorized as COM, so we have no idea what's an ad and what's not an ad, right? So things like that are bigger messes to figure out. If your metadata is already good in automation and you're just figuring out the plumbing, then it's a lot easier.
We actually have a couple questions. Henry Harris came in with 2 questions. Rick, these are for you. Have you worked with the Nextcast automation system? Do you have any filters yet for them?
No, I have not.
Okay. Henry, if you have something out there and you want to work with us, our support guys can help you establish a filter for that. That's pretty much what we've been doing all along. And then will the ISRC code show up on the player?
Right. I just answered that. That's actually not up to us. It's up to the player.
Okay.
Go ahead, Eduardo, Tim.
Yeah, it's really up to the customer. Do you want to see the ISRC code in the player or not, right? Because you can send it from automation, but there's things on the player that we could do to not display that either. But it can still show up in the logs so that, you know, you can have that for sound exchange reports. So we're pretty flexible on that side.
And that control usually happens, or it can happen in the field you send it to. So there's fields that are typically displayed in the player, and then there's also metadata fields that still exist, but most players don't display. And so there's some controls there in the encoder on which one do you send it to, and that usually will dictate whether it displays or doesn't.
Awesome.
I should say we can also, some automation systems export a URL to an image, for example, the album art. And that can be passed up to the CDN through the metadata, and the player can display album art.
I do want to talk about that because we do have that integration today. So if you send metadata, if we can start talking about traditional IC streams, if you send metadata with picture equals in the stream title field, ST Player will display that album art image if you have a fully qualified path to that image. With HLS, it's even easier. You can put it in a specific ID3 tag. It's like artwork 640 PX or something like that. That's a standard ID3 field for HLS, and a lot of players will display album art metadata that way as well. But that's something that's fully supported. I was going to mention that it's kind of one of the more advanced things that you can do with metadata, because 9 times out of 10, folks have this in their automation system. They might be running something like, Xperi or Q or something like that, to where they have adjunct information that they're getting from a third party, including images, and that can get displayed on the player as well. And even on your mobile apps and things like that.
Cool.
Can I get back to Henry's question about Nextcast?
Yeah.
So this is what I mean for figuring out how it works is, so here's something that we have not seen yet. None of our customers have tried to send anything to Nextcast. I would ask Henry then, when you're setting up your StreamBlade or your Duo, collect some raw metadata, send it to us so we know what we're dealing with, and then we basically write a filter for you. And it's based on other filters that we have. It doesn't take us long to do that. We send it back to you. You pop it in, you start processing metadata with that. You may discover, oh, well, there's this one special case here where blah, blah, blah has to happen, and we have to do something with that. Okay, here's version 2 of your filter, and then you're set. That's the way that works. So, and the more we do this, every time we release another version of StreamBlade or Duo, there are more and more metadata filters, because our customers are coming to us and asking for these, and we build them, and then we add them to the to the product. So unless it's something very, very specific to a particular station, then that stays with you.
Awesome. Well, gentlemen, we've come to our end of our seminar here, our webinar, masterclass. I'd like to thank you, Tim and Eduardo and Rick. You guys are definitely rock stars of streaming. I think everybody learned something. I know I learned something today, and I appreciate it. And, we do have a swag bag link for you guys can get some presentations and other information. If you're considering streaming, StreamGuys are an authorized Wheatstone distributor, so they can sell you our hardware, and they can offer you guys a one-stop shop solution for any of our encoders tied up with their services. So if you want to know more about streaming, get in touch with the StreamGuys or Wheatstone. So with that, I'd like to tell everybody goodbye and thank you guys for an awesome masterclass on streaming.
Thank you, Jay. Thanks, Rick.
so much.
My pleasure. Thank you all.
Thanks everybody for tuning in today.